Now for the last case, we are going to learn how to write a quadratic equation when we are given a graph. So as we can see in this example, we have several options. We know the vertex, so our vertex is 1, comma 8. We know our roots, -1, comma 0, and 3, comma 0. We know our y-intercept, 0, comma 6. So if we want to choose standard form, we would need to create a function table where our x coordinates are in consecutive order, for example, -2, -1, 0, 1, and 2. And then we do know our y-intercept. So that's the things we need to know to use standard form, is we have to have consecutive x coordinates and the y-intercept. And then an additional point, and we have several ordered pairs. For factored form, we simply need the roots, our p and q, and an additional point. And again, we have several additional points. For vertex, of course, we need vertex form, we need the vertex, the h, and the k value, which we do have, plus an additional point. So when I'm given a graph, I highly recommend either factored form or vertex form. And honestly, I like factored form because then if I need to convert it to standard, because I've been asked to convert it to standard, to me, factored form to standard is the easiest. If I do choose to originally write it in standard form, we would need to make that function table and again put in some points where we have consecutive x like -1, 0, 1, 2. So we can find that second difference value. And so we could do that. But I'm just going to go ahead and show this example using factor form. So our p-value is going to be -1. Our Q value is going to be +3. So I'm going to start out and insert the values that I know, y equals some a value, and then x minus -1, so that becomes x plus 1, times x minus my Q value of 3. Now let's use an ordered pair. Again, we can't use -1, 0 or 3, 0. Let's pick another point, either the y-intercept or the vertex, or we could use 2, comma 6 to plug in for x and the y value in order to find our a value. So I'm just going to use 0, comma 6. So I have 6 for my y, plug in 0 for the x. And we can see this is going to be a times a value times a value. So this is one term. So this is going to be an easy solving for a. So I have 6 equals 0 plus 1 times 0 minus 3 times a. So I'm going to get -3 times a. Solve for a. So we're going to undo that multiplication. And our a value is going to be -2. So I have y equals -2 times x plus 1 times x minus 3. Now I'm going to convert it to standard form. I'm simply going to multiply these two binomials, x times x, and then I have x times -3, and then x times 1, so that combines to -2x, and then 1 times -3. Now let's distribute our a value of -2 to each term. We get -2x squared plus 4x plus 6. And standard form is usually what you'll be asked to convert it to. So this is factor form, and now we have standard form. And we did know our a value was going to be negative because this quadratic turns down, and our vertex is a maximum point. Okay, let's do one more example of a graph, but this time let's use a vertex form. So our vertex is 4 comma negative 2. So 4 is our h value and negative 2 is our k value. So we have y equals a times x minus 4 quantity squared minus 2. Let's pick an ordered pair to plug in for the x and the y. Again, I'm going to use a y-intercept, 0, comma 6, 0 for x, and 6 for the y. So we have two terms, 1 and 2. So I'm going to say 0 minus 4 is negative 4. And when we square a negative, we get positive. So that's going to be 16 times a. So 16 times a minus 2. We're going to isolate a. We're going to add 2. And we get 8 equals 16a. Divide by 16. And our a value is 1/2. Y equals 1/2 times x minus 4 quantity squared minus 2. And again, if we want to convert this to standard, we have to square our binomial first, then distribute the 1/2, and at the end, combine in the negative 2. X squared, and then it's going to be a minus 8x plus 16. Let's distribute the 1/2 just to this trinomial. And now bring in the minus 2 in our final answer in standard form. Y equals 1/2 x squared minus 4x plus 6. And we do confirm that our y-intercept was 0, 6. So I hope this helps.